f of x is equal to x plus or minus, let's say x minus 3 over x plus 2. And when we want to know, first question is the point 3, 4 on the graph. So the 3, that would be your x. The 4, that would be your y. So we would put 4 in here, or we could also say x and f of x as well. So the 4 will go in for f of x, and the 3, that'll go in for x, so that'll be 3 minus 3, and then here we'll put 3 again in, plus 2, and 4 equals to 0 over 5, or 4 equals to 0. So in order for this to be a yes, both sides would have to equal. Since both sides don't equal, the answer is a no. Alright, and let's see, this was question, I believe, question 3. 2. This is 3, so this is question 4. Alright, next thing is, and we'll call this part A instead of 1. Part B, if x equals to 4, what is f of x? Alright, well here what we have to do is we have to substitute in. So we're going to put in here f of 4 is equal to, and we're going to put 4 in for x. 4 minus 3 over 4 plus 2. And so we get out 4 minus 3 is 1, 4 plus 2 is 6. And it also asks what point is on the graph. In other words, since x is 4 and your f of x, you're looking at x and f of x. Since x was 4 in, f of x is 1 over 6 out. So your answer is 4 comma 1 over 6. Okay. Alright. Part C. If f of x is equal to 2, what is x? So now for our function f of x equals to x minus 3 over x plus 2, we put the 2 in the f of x side. So this is 2 equals to x minus 3 over x plus 2, and then we solve. So we would have to multiply both sides times x plus 2, multiply x plus 2 times x plus 2, and then distribute the 2 here. So that'll be 2x plus 4 equals to x minus 3, and these two denominators cancel out. Alright, so now this is just a linear equation. I like to go ahead and combine the x's first to keep them positive. And so we get x plus 4 equals to a minus 3 or a negative 3. Apply minus 4. we get x equals to a negative 7. And always a good idea to check your work as you do this. Alright, so we want to know what point or points are on the graph of f. So this is still part of part C. What point or points is or are on graph f? Well, you tell me. You're looking at x and f of x again, right? Well, what was x? You should have said x is a negative 7. And what is f of x? Well, f of x, that's what we started with. We substituted that in. F of x is 2. And so that is our answer for that part of the question. Okay. Part D. What is the domain? Well, we look here and we said there were two ways that domain would not be negative infinity to infinity. What were those two ways? Pause the video and try to remember them. Okay. The first one is if x was in the radical. The second one was if x is in the denominator. So which would this one be? In this case, we have x in the denominator. So what do we do to find where we have a restriction in our domain? We would set the denominator equal to 0, right? And then solve. So we would take that x plus 2, set it equals 0, and then solve. And so we apply minus 2 and get x cannot be a negative 2. Because if we put a negative 2 in here, right, you got negative 2 and positive 2, it goes to 0 in the denominator. It's undefined. Alright, so on our number line, we can do anything but negative 2. We're going to negative infinity this way and positive infinity the other way, or negative infinity in the negative direction, positive infinity. So this will be from here, you should be able to figure out it's going to be infinity going in the negative direction to negative 2, open, union, negative 2 to infinity. Alright, that's our domain. Okay. Let me draw a line here to separate these parts. Okay. We also want to part E, list. Part E, list the X-intercept. And this part you've got to show algebraically how this is done. So to find the X-intercept, we set y equals 0, solve for x. To find the Y-intercept, set x equals 0, solve for y. So we would put 0 in here for f of x, and then we're going to put in there the x minus 3 over x plus 2. And then solve for, we've got to multiply out the denominator, which makes that go to 0. So technically, you could just set the numerator equal to 0. But if you had to, You could go with the Y-Intercept method and just stay consistent with that, and then be fine. And so we solve for that. We apply plus 3, and we get x equals to 3. And so you would just leave it like that. You would not put this particular one in a coordinate point. All right, and then F, part F, lists the Y-intercept. Make that better looking. There we go. So now we're going to set x equal to 0 and solve for y. So we're going to take our function again up here, and we're going to put 0 in for x. X minus 3 over x plus 2. So this will be f of 0, put 0 in for x, 0 minus 3 over 0 plus 2, and we get negative 3 over 2 out. And so you would just write that as just 3 over 2. There'll be space for that. Okay, and so that's that particular problem.